And with that, I would like to welcome everyone to our next session on Intel software with Edmund Price.
So thanks everybody for joining this call. My name is Edmund Price. I'm a tools business development manager here at Intel, in charge for customers who have an interest in our tools. And I'd like to use the next 50, 60 minutes talking about the Intel new oneAPI toolkits and its components. And actually going to start with a short introduction, maybe it's a bit longer than a short introduction, about the motivation to come up with the oneAPI concept, which at the same time is also a standardization type of concept. The agenda which I've prepared for today, going to cover quick evolution of upcoming particular HPC enterprise computer architectures, how they're going to work. Basically, it's talking about homogeneous to heterogeneous concept that we're going to see out in the future. Then I will talk about oneAPI in a bit more detail, specifically about the language standardization efforts which are going on by the different parties involved. And then I will move on to the Intel oneAPI specific toolkits which we're offering. Many of you might have heard about Intel Parallel Studio, which was a suite of tools which will be replaced now with the oneAPI toolkits. And that will be something very brief, talking about enabling activities which are going on, about the ecosystem, about migration activities. I think for those people who would like to use oneAPI, I have a lot of resources and useful links pretty much at the end of the presentation. And then I'm going to sum up with a call to action. So let me start right now with a quote from John Hennessy and David Patterson, and I've also included a very nice article or a link to an article which I highly recommend to look at. It's talking about the history and of computer architectures and what is going to happen according to these gentlemen. They call it the Cambrian explosion in terms of novel and future architectures. Some of the stuff I'd like to skim over very quickly. So for those people who have been around for a while, there have been a long ride from originally single core processors, and in the mid 2000, 2005, 6 specifically on the HPC side, maybe on the individual notebooks and desktops that happened a little bit earlier. The industry was moving from single core to multi-core CPUs integrated in one socket, and going along with it was introduction of parallelism and new development tools, and also a new thinking of writing parallel application was required, which is much more complex than just writing serial applications. I mean, time has moved on, and we have moved from the homogeneous, or just one type of device, so CPUs in the past, moving to heterogeneous environments where the parallelism is shared between CPUs and additional accelerators, like in this case, discrete GPUs. And in that context, I mean, and that is a slight detour in terms of before looking at the future and future concept. So with a mix of GPUs and CPUs, the workload has to split up. Many people might know that, but for those who are not so much involved in it, so people who use discrete GPUs look into the workload specifically for typically a smaller portion of their code. It's typically less than 5%, around 5% of the code, which is massively parallel. So an area that makes sense to be parallelized and that make use of the many small execution units which are offered by a discrete GPU, and that's the part which gets parallelized, and that's the small part that gets you a lot of performance speed if it's done properly. That doesn't mean that parallelization is not happening on the CPU. A CPU is still parallel, and some parts still for performance gains should also be in parallel. So it's the mix between GPUs and CPUs that makes the performance. So let me go back. Now we are looking even forward out there in the future. What is potentially going to happen and how potential architectural architectures and the mix of the different devices are going to look like. So there's a plethora of different examples where it's not just the CPU and GPUs that are going to be mixed. It's also AI accelerators that might come into play, and the same goes for FPGA, and the combinations, the permutations are plentiful, I would say. And we're going to see. And it's important that for this environment, you come up with a good development environment. That's what oneAPI will address. And I'm going to come to that a little bit later. Before going into that, let me close with this slide with regard to future architecture. So it's not just about the XPUs, so to speak, CPUs, GPUs, AIs, FPGAs, and so forth. We also have to take into account the memory. Where's the memory located? Is it close to the individual devices? Is it shared? So these are things that, as said here, adds to the fun of writing powerful applications. So before going to heterogeneous systems, life for developers was relatively easy. There was a compiler, and even if there were different compilers, let's say C++ compilers available for the developers, and of course libraries and so forth too, changing the CPU was not a big thing, because compilers were adhering to standards, and switching between compilers was quote unquote relatively easier. It doesn't mean if you switch from compiler to compiler, maybe to a more performant compiler, or you need to switch to one that is running on a different CPU, that you don't get warnings and maybe even error message that you have to work on. But fortunately, I mean, compiler is a compiler, and compilers adhere to specific standards, specifically on C, C++, from the ISO C++ standardization body. Situation changes when you're moving to a mix of architectures, so like here, CPUs, GPUs, or we call it here XPUs. Then, yeah, you still have the compilers and the libraries and so forth. But the individual vendors are coming up with solutions which are sitting on top, which often are proprietary solution, and that is what you see in the market right now. So the leading vendors of discrete GPUs are coming with proprietary solution, which makes it very difficult for, and which is a desire about developers if they want to move, and they want to move between the hardware. Proprietary solutions make it much more different. So we have, as it said here, kind of a walled garden that we would like to avoid, with ideally a standardized approach for heterogeneous programming. And that is what oneAPI is addressing. So I'm using this logo, which you see here, for the standardization efforts. There's another logo which I'm going to show later, which is referring to the Intel implementation, Intel solution, toolkit solution for oneAPI. So what does the developer want? I have indicated a little bit. I think there are mainly three things that the developer is interested. He wants to have the freedom to use the architecture, the XPU of his choice, irregardless of the type and irregardless of the vendor. Secondly, what he wants is when he moves from one vendor to the next one, from one architecture to the next one, from one XPU to another one, he wants to have a reasonable level of performance, so it should be in the same range, so to speak. And third, he also would like to have the assurance to have a trustworthy solution, confidence that his source, his one source that runs on different hardware is maintainable and useful and works out there in the future. So these are three guiding principles. And that's what the oneAPI solution, the oneAPI industry initiative, which is worked on by various industry partners, Intel being one of them, that oneAPI basically is driving. And you see the core things of the oneAPI industry specification, which is shown here on the stack, pretty much in the middle, and the highlighted one consists of three different things. So there is a direct programming model and a standard behind it based on SYCL, and I'm going to talk about that a little bit later, what that is, and how it relates to Intel solution, how it relates to the ISO C++ solutions. There is also, that is important, an API, an open API for a lot of libraries which are required out there in the market. So when it goes to mathematical simulation, there's a lot of stuff that people typically use. And if you want to address heterogeneous environment, different architectures from different vendors, then you need a standardized API. That's exactly what is offered here. And last but not least, in order to bridge the gap between the direct programming solution, the APIs for the libraries, you need a low-level hardware interface that helps you to write the right drivers and to bridge the gap between the software and the specific hardware from the different vendors. So these are the three things which are in there. So let's look a little bit deeper at them individually. So with regard to the compiler, everything is based in oneAPI on the ISO C++ standard, actually the 2017 version at this point in time. On top, the Kronos group comes in. The Kronos group, for those of you who might not know, started quite a while ago addressing heterogeneous programming. Their first attempt was OpenCL. OpenCL has a couple of disadvantages, specifically when it comes to performance. So in terms of direct programming, they have come up with a standard, with an extension that they call SYCL. So SYCL is an approach, an extension of C++ to develop heterogeneous programming applications. And on top, there are what we call community extensions. So when you drive standards, you want to test and try out stuff before it hopefully goes back all the way into the ISO C++ standard. So community extensions that the Kronos group and even Intel and others have come up are first attempts to enhance the C++ standard with features which are useful for heterogeneous programming. And I'm going to show a few ones on the next slide, so it becomes a bit more obvious what I'm talking about. And these community extensions will be tested, and as I said, tried out, and over time we'll make it back into the standards. That's the idea. So one of these extensions, for instance, was the buffer memory abstraction that the SYCL Kronos group came up with, and which was introduced with the SYCL standard 1.21. It's a very powerful and elegant way to express data dependencies. It has a couple of disadvantages, like it's not supporting the pointer concept. And for that, Intel came up with a unified shared memory extension, which we put into our SYCL implementation, which we call DPC, Data Parallel C++, which was exactly addressing and offering these features for simplifying porting applications to different accelerators. But that was not the only extension that the Data Parallel C++ offering from Intel is providing. We had a couple of additional extensions like subgroups, group algorithms, and so forth. which all of them made it back into the SYCL 2020 standard. So I talked earlier about the SYCL 1.21, which had the buffer extensions, and all these ones which we introduced have made it back into the latest standard, which is the SYCL 2020, which hopefully will make it in the future then, since the ISO standard is a bit slower, doesn't change its standards on a yearly basis. So the idea is to bring that back and make it part of that future C++ standards for heterogeneous programming. There are more extensions coming up. For those people who are interested, there's this link, this tiny URL, which will give you more insights. So what is happening on the ecosystem? So SYCL, so to speak, being the quasi-standard right now for heterogeneous programming, the data parallel C++ implementation from Intel on the left side, supporting different CPUs, and also with some manual effort, you even can run data parallel C++ on AMD and NVIDIA GPUs. But we are not the only ones. Again, I mean, that's the beauty of a SYCL. Different people can come up with their solution for their hardware and for the development environment. And you see the current state of the union. So there is a company called Codeplay that has the last 2 to 3 years working on solution, come up with something. Xilinx has a solution. The University of Heidelberg developing a HipSYCL solution, which had predominantly originally AMD GPUs in mind. And there are additional ones which are listed here. And hopefully in the future, even more people are going to join the bandwagon. Regarding the oneAPI libraries and the standards, I mean, typically you find the libraries which are needed in enterprise and HPC environments. So from math kernel, video processing, DPC, additional DPC++ libraries, video libraries, deep learning libraries, data analytics libraries. All of that stuff is standardized and can be found, by the way, also in our solutions. In terms of the ecosystem, that is the status about, give and take, about 2 months ago. There are well more than 100 companies in the meanwhile that have expressed their support for the oneAPI solutions. Don't want to read out of them. It's an impressive list in the meanwhile. People enjoy, people like the standard, and for that reason are supporting it because of all the benefits that I was describing earlier. This is something that is very valuable to the system. And to complete the picture, and you have seen that in the SYCL standard, we were talking about NVIDIA solutions. So with Codeplay, they came up with a solution. Another one, for instance, is using one of the libraries, the DNN library, on an ARM-based solution on one of the biggest data centers in the world, the Fugaka ones, and there are more which are listed here. So to sum up on the oneAPI standardization initiative, so what we're talking here again is a cross-industry and open standards-based unified programming model that delivers the one source approach for developers, giving them a great experience and make it easy for them to switch between heterogeneous environments, so across processors and different accelerated architectures. And it makes it easy, so you don't necessarily need to have a PhD in order to do effective parallel computing. This solution should be accessible and easy to apply for any developer out there in the market. So far, I've talked about the standards. Now I'm talking about the Intel oneAPI Toolkit solution, which are specifically targeted at this point for the Intel hardware. So for Intel x86 CPUs, for integrated graphics from Intel, for future discrete graphics, for FPGAs, and so forth. And you might have seen that the logo has changed. So the logo that we're using for the toolkits is the one that is shown here. And of course, I mean, we are addressing the same part of the stack, and there are a couple of additional things which I'd like to mention. So Our oneAPI solution includes a compatibility tool, which I have an additional slide. So it's a tool that migrates code from CUDA to oneAPI, to DPC++, to SYCL. I will talk about the languages. So far I've mentioned C and C++. I will talk also about our Fortran offering, which comes into play there, and the respective libraries which are required for offloading. The libraries that you've seen earlier, all of these libraries are in here. Many of them have been around, have been used with Parallel Studio for many years, and which are, of course, being integrated into the toolkits, and now not only available for CPUs, but also available for XPUs, for GPUs, and so forth. And the same goes for analysis and debug tools. So many of them, for those who have used Intel Parallel Studio, they know about vTune, they know about Advisor. All of that stuff has been extended now to discrete graphic, so to XPUs, if you like. The DPC++ compatibility tool that I was just talking about takes CUDA code, so you can take the CUDA source code, apply the compatibility tool about 90 to 95% based on experience on code that has been migrated to oneAPI, gets transformed into a human-readable DPC++ code with some inline comments. So with some minimal additional manual attention and fine-tuning, you get the final DPC++ source code, which allows you to run then the code on CPUs, XPUs, and with some manual specific drivers, you can even run it on non-Intel hardware. Data Parallel C++ is, and I mentioned that earlier, an implementation of the current SYCL 2020 version with a few additional community extensions. So that is something which is in flux, and whatever is useful will very likely make it back into the SYCL and hopefully then into the ISO C++ standard. The DPC++ solution that is similar with our classical compilers aims to be the best implementation of the SYCL C++ standard. Short introduction in terms of how the compiler architecture looked like. Simplified view historically. So you take the source code, you have a front end, C++ front end, for instance, and which creates an intermediate representation. You optimize the code, and then there's a code generator that in the backend that translates the original intermediate representation into the target code, Intel hardware specifically. There are a couple of, just on the C++ side, the first three, and we're going to see that in a bit more detail. So give me another 2 slides where we have a nice matrix that shows the overview of the different Intel compiler drivers. And this is just the view on the Intel compilers. The first 3 are pretty much the ones that you might know, the classic compilers, and the ICX and DPC++ are the new heterogeneous implementation. The compilers are pretty much the same. It's just the compiler drivers, which are different and differentiate a little bit. Both of the last and also are based on the new LLVM standard, which is also a modular compiler architecture, which allows to reuse specific parts, so like the front end, and use the LLVM compiler. So you see that here, the front end translates into a standardized LLVM intermediate representation, which you're using now instead of a proprietary one, and then using the LLVM optimizer, the code generator that you've seen before, but now making use of the LLVM IR. And this will be used, and this will actually in the future lead to the fact that we will move over time from our classical Fortran C++ compilers that you know, which are predominantly for CPUs, and we're going to use in the future, and will offer and we'll ask customers to use the LLVM-based compiler. So at some point, in not so far distance, we actually on CC+, C, C++, this will happen already by the end of the year. We will deprecate the current C++ compilers, and will then have customers work with the LLVM-based C++ compilers. Regarding the Fortran compilers, this will happen a bit later, maybe a year later or so. But I'd like to point out, and we're going to see that in a minute, the productized versions are already there. People can use it, and for C++, I will show also a couple of benefits, how much performance you can get out of it. So for developers, the call to action here is start programming already now. Consider going for commercial development to the Intel LLVM-based compilers. Here's the overview. So I'm using the word classic compilers. I've used it already, so you see that here in the two entries, the first line and the fourth line. The first one is the current C++ compiler. The fourth one is the fourth line is the classical Fortran compiler. All of them are targeted for CPUs. They have OpenMP support, but for heterogeneous programming, they don't have support. That's the third column here. And in the future, and these things are available already as part of the oneAPI toolkits, we are addressing with new compilers, the LLVM-based compiler, CPUs, GPUs, and FPGAs. For C++, there are two versions. One driver includes FPGA, the other one does not. So you need to pick the right one. And for Fortran, we are supporting now also with the LLVM version CPUs and GPUs, and heterogeneous programming is supported with OpenMP. I promised to talk a little bit about performance. So what you see here is a comparison on some benchmarks, public benchmarks, which are available by comparing different solutions. So the baseline is the GCC 11.1 compiler, and then we are comparing to the plain vanilla LLVM compiler available in the market, to the Intel Classic compiler, and then to the Intel LLVM-based compiler, which creates and gets you the highest performance for this benchmark. Of course, I mean, the situation will be different from workload to workload, but given these benchmarks are kind of providing some reference, some good reference, representing a situation that you might find with your workloads also, there is a good chance that you will see similar benefits, and that's what I said earlier. So it's a good consideration, considering moving to the new LLVM-based compiler soon. There's also another benefit going along with the new LLVM compilers. Their compile time is faster, and that's basically what is shown with these two graphs that you should see here. So there's well more than 10% gain in terms of compile time. I mentioned OpenMP. OpenMP is a standard that has been used for quite a while for parallelization, typically on a node or on the socket initially, but it can be used also for offloading and heterogeneous programming. It can be used both for C, C++, beside DPC++, as I said earlier, also offering heterogeneous programming. And OpenMP, specifically when you have a Fortran program, is the preferred choice, or the choice that you have. So much I've talked a lot, and that is pretty much a core part of oneAPI is the programming and some of the libraries. So let me add a few things about the analysis and debug tools. I mentioned that already. So historically for the CPU, we had the advisor, which allowed to optimize parallel applications, specifically when it comes to vectorization. vTune was the choice for performance optimization in general, also for parallelism, not so much on the vectorization side, but in general. A good tool, a widely used tool for that purpose. And we have the debug tool, a GNU debugger, and interdistribution. All of these three tools now have the functionality not only to analyze CPUs, but also GPUs, FPGAs, and so forth. For each of the tools, I have one slide, and I will not spend a lot of time because I'm short on time probably, and therefore going to rush a little bit through that. So you're going to see here what the vTune profiler is doing. So it allows you to look into your code. It shows you the bottlenecks here on the right side, specifically by using colors, by using time bars to give you an indication where the bottlenecks are, and points you back to the source code, like the one shown here, either on the language level, Fortran, C++, or all the way down to the assembler code. It also has another nice function. It's going to start a few years ago. We called it the vTune, or as part of the vTune profiler, that gives you an indication how the system going to look like, if there are bottlenecks there, how the data transfer rate is going to look like. And it even gives you a view how your system is set up, and you can view whether a system, maybe a system in HPC is properly set up or things are missing. The advisor has one new tool. We call it the offline advisor. It's a tool that gives you an indication of what if scenario, how much performance you gain, you would get by moving from a CPU only to a mixed, in this case here, using a GPU, how much performance gain you get out of it. I mean, for those of you who are already used to the roofline analysis that has been around for a while, but also has been extended to GPUs. That's the box here to the lower right on the right side. Yep, as I said earlier, Intel is offering the GNU debugger. That's a distribution that we're offering. Again, useful now not only for CPUs, also GPUs. I think I talked about libraries already. That is a little bit a replicate of what we earlier. So let's move on a little bit. I think let me talk about the oneAPI suites that exist. We call them the toolkits. There is a base toolkit that is the basis of toolkit that you need if you use oneAPI. It includes pretty much all the libraries, includes C++ and the SYCL compiler plus Python application, the Python compiler, which is optimized for inter-platform. On top of the base toolkit, there are individual toolkits for specific markets, like the enterprise HPC market. So you would mix the base and HPC toolkit. For the embedded market, there's a separate one, which you would mix with the base toolkit. People who are interested in rendering, so visualizing their data, there's a rendering toolkit with a lot of libraries and functions in there. I have a separate slide to that if you're more interested in that. And there is, and that is an interesting one to many people who are interested in classic machine learning and in deep learning. There's an optimized AI analytic toolkit with frameworks and a lot of libraries. And I have a separate slide that talks in a bit more detail. And there's another toolkit, particularly for people who are using or writing applications for embedded environment, for applications which are running on the edge. The OpenVINO is a development kit with a lot of examples and working closely with the C++ compiler for deploying applications, as I said, on the edge. We have commercial toolkits with commercial support. So like we had in the past, Parallel Studio, we have that now with the toolkit. So the Parallel Studio is going to be replaced typically with the base toolkit and the HPC toolkit. For those who are interested in the commercial solutions and commercial support, here is a list of the typical benefits you get: access to a website where you can raise tickets with issues that you might have, getting access in an escalation path to the software engineers and so forth, and further assistance, including even training and so forth. And again, this is, I think, a good slide, specifically goes in more details, kind of an eye chart. So maybe when you have more time, like I have here for my presentation, feel free to look at it. This is an overview of the HPC base and HPC toolkit. The light blue are the ones are the components which are in the base toolkit. The dark blue ones are the add-ons from the HPC toolkit, and the yellow ones are referring as a reference to those people who originally were using ParaStudio. So if you use ParaStudio, everything that you knew from the past is still in there, but now you get the access to a toolkit that supports not only CPU, but also heterogeneous programming. This is a slide that talks about the various libraries that we have for ray tracing, for renderization, rasterizing, image denoising. So basically it's about visualizing your data and giving you the opportunity to provide high quality images to visualize your data. I talked about the AI toolkit, so that includes performance optimized frameworks for TensorFlow, for PyTorch. There's an entire model zoo that you can use. So a toolkit that helps you to accelerate coming up with models and AI deep learning models. There is an optimized Python distribution in there with library extensions like scikit-learn, XGBoost, and also for data analysis, which helps you to accelerate to get to the results much quicker. So instead of going to the plain vanilla solutions which are out there in the internet, feel free to use the Intel implementation, which are optimized in terms of performance and can be downloaded from different sites and exist also as containers, by the way. Last word on the OpenVINO toolkit, I mentioned that already. So that is deploying deep learning solutions, models that have been generated by the frameworks, PyTorch and others, TensorFlows, and now optimizing for your target hardware, which might be tiny little processors or even bigger ones. This is a solution which exists for Intel processors and helps you to implement the solution very quickly. It's typically addressing the software developer who's writing applications on the edge. People who want to use the one and try out oneAPI toolkits, there's a kind of a sandbox. We call it the Dev Cloud. There's a link, so there's an easy access. You get access for 120 days, which can be extended, giving you access to the latest hardware and to samples and to the tools. And now I'm skimming relatively quickly of examples. So a lot of people have started doing enabling applications, and those who allowed us to promote it, we put it into something which is called the Intel oneAPI catalog. Here are a couple of examples, some of them specifically here coming from Europe. That's the reason why I'm showing them here. So CERN, Gromex, and others came up with solutions that are running in heterogeneous requirements. For those of you who are interested, you can click on that link here on the picture, and you will get a testimonial from Eric Lindahl. He is the key stakeholder with regard to the Gromex development. As BKM, specific for developers who are interested to learn which experience other people had when they went converting or migrating code from CUDA to oneAPI. Here are a couple of examples. You can click on the individual screenshots, and that gets you to the sites. Here are a couple of resources which I think are useful in order to get started, in order to learn about it, links to webinars, links to the industry initiatives, and also to the ecosystem. Intel has come up with a lot of additional material, a magazine, which we call the Parallel Universe, which comes up on a 3-month cadence. You can subscribe to it, just click on it, you get to there, and And there is also additional information in the developer product insight. You also can submit to it in order to get more information. And with that, I hope I didn't exceed my time. I'm coming to my last slide, which is the summary of what I've talked about in the last 50, 60 minutes about oneAPI. It's a cross-architecture heterogeneous initiative. And the second part is the Intel oneAPI Developer Toolkits, which is a solution and implementation of the oneAPI standard for heterogeneous programming. It exists, it can be used, and I encourage developers to start the migration, moving from the classical Intel compilers to the LLVM-based compilers, and writing applications for CPUs, but also for heterogeneous programming. And specifically for people who have used CUDA in the past, here's a valuable alternative that comes up with the one source solution that will work on different hardware. So with that said, I will conclude. I don't have a watch in front of me, so I hope I was doing fine on the timing. And we'll close here. Thank you.
Yeah, thank you, Edmund. Thanks for a great presentation. We do have some minutes left, and we also do have some questions, if you would be able to answer those now.
Sure, fire ahead.
Yeah, so here's one. I'm an old Intel Parallel Studio user. Is the upgrade promo campaign still available to upgrade to oneAPI?
Should be available, definitely. Yeah. I mean, it's an easy transition. Yeah.
Okay.
So
yeah.
I suggest. I mean, this event has been organized by Alfasoft, which is an elite reseller of our software development tool. So I encourage you to work with the representatives of Alfasoft.
Yeah, just send us emails or questions, and we'll do whatever we can to help you. Have another question here, if you're able to take that. Will it be hard for me to change from the traditional Intel C++ compiler to the new LLVM C++ compiler?
I mean, we made it as easy as possible. I mean, it's the same C++ standard that you're known. But of course, if you want to use application or heterogeneous programming, then I mean, you need to learn some additional stuff. I was talking about the community extensions which have been implemented in order to enable heterogeneous programming. So there is some stuff that you need to learn. And maybe what I should, and that for that reason, I provided the many links. There are also links to training material. We will have future training out there, also here in the EMEA or European region, and I'm sure Alfasoft going to promote them when they become available. And I'm more than happy to point you to training that we have done recently. So we did, for instance, a training for one of 4 European HPC centers through the EuroCCC organization. That is something which is accessible, was recorded. That goes much deeper in terms of what I have done. So there were sessions individually for the libraries, for the analysis tools, for the compilers. So stuff that I didn't have the time to touch base on and where the specialists are talking about. So yeah, you need to learn new stuff. I think it makes it, of course, a bit more complicated, but as I said earlier, you don't need to have a PhD in order to write heterogeneous programming.
Okay, and one last question here. You're transitioning obviously from classic compilers to LLVM-based compilers. Is there a timing difference between Fortran and C++?
Yeah, there is a slight one. I think I mentioned a little bit earlier. So we will deprecate the classic compilers, C++ compilers, end of this year, and encourage people to, when they productize and write commercial code, to go to the Intel C++ LLVM-based compilers. That does not mean that we stop supporting the classic compilers, but we will not further develop it, right? The last CPU, for instance, is this, for those who know the code names, it's called Sapphire Rapids. That's the most actual, the currently launched Intel CPU, Sapphire Rapids. So that architecture is supported still by the classic compiler, but that's the latest one. So any future CPUs and also GPUs will be supported by the LLVM compiler. Regarding Fortran, the deprecation will be give and take a year later. But we have a commercial product, and people can start also with Fortran to develop LLVM-based code with these LLVM-based compilers, including Fortran.
Okay, great. Thank you, Edmund. And I think with that, we can end your session. If anybody of the audience have any additional questions, please just send them in, and we'll make sure that Edmund helps us answer those questions later on, and we'll send all the questions and answers in an email, hopefully mid next week. So thank you, Edmund.
You're welcome.